Everyone, and welcome to IB Methodology, your space for mastering IBDP mathematics. Now in today's video, we are going to solve May 2025 Time Zone 1 Paper 2. So let's start with the first question. So it says there are 2 points which are lying on the circle and the radius is given to us as 19.5 and the angle is 210. Now, what we have to find out at first is the area of the sector BOA. Now, to solve A part, we will be using area formula as theta upon 360 degree into pi r square. As radius is 19.5 and angle is 210, so I will be substituting the values like this, 19.5 whole square. Now, when you will use your GDC, you will get the answer as 696.844, which I can also write as 697 centimeter square. So this is how we got the area of the sector. Now in the B part, they are asking the radius of a cone. Like from this sector, they are making a cone. So we have to find the radius of that cone. So we will use arc length formula first, which is theta by 360 into 2 pi r. Now again my theta is 210 and radius is 19.5. Now after using your GDC, you will get answer as 71.4712. Now we have to calculate the radius of the cone. So we will use the circumference of the circle formula, that is 2 pi r, and circumference here is nothing but the arc length. So I can equate it with 71.4712, that is equals to 2 pi r, and when you will use your GDC, you will get your radius as 11.4 centimeter. Now let's move to the next question. In this question, the function is given to us as a tan 2x plus b, and we have to write down the period of f. So to write the period, first we have to know that period of tan x is pi, and we are given with tan 2x, so its period will be pi by 2. So what is important here to note is multiplying by a, which is here, or adding b does not change the period. This is what you have to remember. Now the graph passes through these 2 points and we have to find values of a and b. Now since the graph is passing through these 2 points, so we can start with the first point where we can substitute x as 12, pi by 12 and y as 5 in the function given to us as a tan 2x plus b. So when I will substitute, I will get 5 is equals to a tan 2 into pi by 12 plus b. So I can write this as a tan pi by 6 plus b, and tan pi by 6 is nothing but 1 by root 3. So I can write this equation as a by root 3 plus b, and this becomes my equation number 1. Now I will use the next point, which is pi by 3 comma 7, and I will do the same thing here also. So I can write as 7 is equals to a tan 2 pi by 3 plus b, and tan 2 pi by 3 is nothing but minus root 3. So this is how I get 2 equations. Now if I use GDC and put these 2 values, these 2 equations in the GDC, I will get a as minus root 3 by 2 and b as 11 by 2. So this is how I'll get the values of a and b. Now let's move to the third question. In this question, the function is given to us as hx, and it has a tangent which is tk, which is passing through the point hk comma h of k, and we have to find the gradient. Since the function is given to us as hx, so gradient will be h dash x. We will be using the rules of differentiation 15 as it is. cos x derivative is minus sin x. So we will write it like this. And we have to take out the derivative of pi x by 50 also, which is nothing but pi by 50, as x derivative is 1. And 15 is a constant, so derivative of 15 becomes 0. So I can write it as 15 minus pi by 50. I am just rearranging sine pi x by 50. This is how I get my gradient of the tk in terms of k. So we have to write in terms of k's. It means I can replace x by k and I can write it as pi by 50 sine pi k by 50. So this is my A part answer. Now it says that the angle between tk and x-axis is pi by 8 radians. We have to find k. Now angle, what they are talking about is this angle. But we take angle always from the x-axis. So to find k, we can find this angle, if I name it as theta, 180 minus the angle which is given to us. So I can write it as pi minus pi by 8, which is nothing but 7 pi by 8. So I will be using this angle. I am using the result of first part. I will equate it. So I can write as 7 pi by 8 is equals to 15 minus pi by 50 sine pi k by 50, and you can use your GDC. So you will get k value as 7.242. So this is how we will get a k value. Now let's move to the fourth question. In this question, the population P has a rate of change given to us as this, where T is the time measured at the start of 2022. This is what we have to use. And at the start, the population was given us as this. Based on this model, we have to predict the population at the start of 2026. Now, since they are talking about the population, but we are given with dp by dt as this 0.0145 t. So since this is the rate of change, so we have to integrate both sides with respect to t, and we have to first find out the p value. So if I can take this as common, and e to the power x integration is e to the power x only. So I will use this, and since it has fx in the numerator, so derivative of the power will be 0.0145, and there will be a c because it is an indefinite integral. Now to find c, we have to use this statement. At the start means when t is equals to 0, p is given to me as 6.78 into 10 to the power 6. So I will put this in the above equation, which is 6.78 into 10 to the power 6 as 14000 divided by minus 0.0145 into e to the power. If I put t as 0, it will become 0. So if you will use your calculator, you will get c as minus 392413.7. So this is how I'll get my C. Now we have to find the population at 2026. So if you compare, your time is 4 years because we are talking about 2026 and the start was 2022. So I can put T as 4 in my P function, which is 104,000 upon 0.0145 into, instead of T, I will write 4, and C, I already got 392413.7. So when you will use your GDC, you will get P as 6375834.1 and so on. So I can also write this as 638 into 10 to the power 6. So both answers are acceptable. Now let's move to the next question. Now in this question, the measurement of arm span, which is a centimeter, and foot length is f, are taken from a large group of adults, and the functions, those two functions are given to us as, for the regression line, f on a is given to us as this, and for the regression line, a on f is given to us like this. Now each regression line passes through the mean point. So my first thing is to find out the mean point. Now it says, by using appropriate regression line, estimate the arm span for an adult with foot length 19.8. So to solve a part, we will use a equation as 2.89f plus 99.3. I will put my f value as 19.8. So when you will use your GDC, you can put this equation and we will get a value as 156.522, which I can also write as 157. So my arm span is 157 centimeter. Now for the B part, they are telling us to find the mean and so to find this, first we have to find the mean point. Mean point is the point of intersection. So we can equate f or a for both. So I can write my f is given to me as 335a minus 32.6, and from this a, which is given to me as 2.89f plus 99.3, from this I can make f as the subject, so I will get upon 2.89 as my function. Now this is my first equation, this is my second equation. I can equate both and I can use my GDC, and after equating both the values, I will get for f, because we are equating for f, so it is 686. And if you will equate both a values, we will get answer as 20.89. So I can write that my mean arm span is almost 160 centimeter. This I can round off to 160, and mean foot length as 20.9 centimeter. So this is how we'll solve B part. Now let's move to the next question. In this question, the function is given to us as 4 cot x plus sin x, and we have to write fx in terms of sin x and cos x. So we will use basic conversions. So first I will write the function cot x plus sin x. So cot x is nothing but cos upon sin, and this sin x will be as it is. So I got my function in terms of sin x and cos x. Now for the second part, it says sketch the function and write the values of the x-intercept. Since it is paper 2, so we can sketch the function in GDC also. So when you will sketch, you will get a function like this, where this point is 1.81, which is the x-intercept, like this. This is how we'll do the second part. Now for the B part, it says find the value of f inverse 2. Now to find the value of f inverse 2, we can write it as fx is 4 cot x plus sin x for the B part. Since it is given to me that we have to find f inverse 2, so if I put it equals to x, so I will get 2 as fx. It means instead of this f, I can put 2, so that will be 4 cot x plus sin x, and when we will use your GDC, we will get x as 1.32. Now in the C part, it is given to us that sec alpha is 1.5. We have to find alpha. So to solve this part, first I will replace x with alpha. So I will get 4 cot alpha plus sin alpha. Or I can also use as 4 cos alpha by sin alpha plus sine alpha. It's your wish which f of alpha you want to use. Now I can use SOHCAHTOA. So I will first make a right angle triangle representing the angle as alpha. Now since sec alpha is given to me as 1.5, which I can write as 3 by 2. So from SOHCAHTOA I can write this as 2 and this as 3, and when we will use Pythagoras theorem we will get perpendicular height as root 5. So from there I can write cos alpha as adjacent upon hypotenuse, so that is 2 by 3, and sin alpha as opposite upon hypotenuse. Now I will put these two values in the function. So my f alpha becomes 4 2 by 3 whole divided by root 5 by 3 plus root 5 by 3. Now when you will use your GDC to simplify this, you will get 4.32 as your answer. Now let's move to the next question. This question, it says that at 9 a helicopter is located at a point 3.5 relative to the point O on horizontal ground, and the x direction is in east, y direction is due north, and the z direction is vertically upwards. It means it is coming out from your paper. And the distance is measured in kilometer, and the helicopter is flying at a constant height. Now the helicopter position is given to us by this, where this 10, minus 25 and 0 will be your direction vectors. We have to find the speed of the helicopter. Now to find the speed of the helicopter, I can write that speed is nothing but the magnitude of velocity. So I can take the magnitude of direction vector as 10 square minus 25 square 0. After solving this, we will get 108 kilometer per hour as our answer. Now in the B part, at 10 the helicopter begin to descend, and during this descent the helicopter vertical height decreases at a rate 16 kilometer per hour, but the horizontal velocity remains unchanged. And we have to find this angle beta, which is the angle between helicopter direction of travel and the horizontal, and we have to give our answer in degrees. So for B part, if I try to use right angle triangle and I can apply SOHCAHTOA, so I can write my tan beta as the height decreases at this rate upon the answer which I got from A part. So after solving this, I will get my beta as 8.45 degrees. Now we have to remember to put our GDC in degrees before solving this. Now let's move to question number 8. In this question, we have two functions ft and gt given to us, and ht is sum of these two functions. So A part says that show that ht is this. So since they both are sine, it means they are automatically the imaginary parts that are given to us. So if I write the right side of the question, which is this, I will try to open the brackets. So this will be plus I e to the power 2ti plus 3i. On further solving, I can take I common. So it will be 2t plus 1 plus again I can take I common 2t plus 3. And since they are the imaginary parts, so I can write them as sine 2t plus 1 plus for the second one it will be sine 2t plus 3. And if you see that this is nothing but ft and this is gt. So I can, and it was given to me that ht is sum of ft plus gt. So this is how I can solve A part. Now in the B part, it says write e to the power I plus e to the power 3i in the form r e to the power I theta. So for this we can directly use our GDC, and I can write that e to the power I plus e to the power 3i after using my GDC will come out as e to the power 2i. So if I compare this with r e to the power I theta, so I can say that magnitude is 1.0806 and it keeps on going, and theta is 2. So these are the answers of B part. Now for C part, it says write ht in the form p sine 2t plus q. Since we are talking about sine, so it means we are again talking about the imaginary part. So for the imaginary part, I can write ht as imaginary part of e to the power 2 plus I into the sum answer is coming as this, as you can see from B part. So I can use my GDC and I can write it like this also, e to the power 2i. I can further simplify this and write this as e to the power 2t plus 1 into I. So this is nothing, sorry, it should be 2. So this is nothing but sine 2t plus 2, and I can write my magnitude in this form. Now if I compare this with the question, which is p sine 2t plus q, and on comparing I can say that my p is 1.080 and q is 2. So this is how we'll solve C part. Now let's move to question number 9. Now in this question we are given with the differential equation 2x upon x square plus y, and the solution curve passes through 1, 0. Using Euler's method, the step value is 0.25. We have to estimate the value of y when x is 2. So first of all, to use Euler's method, we use two formulas, which is xn plus 1 is xn plus the step value, and yn plus 1 is yn plus the step value multiplied by the derivative function which is given to us. Now these two formulas are there in your formula booklet. So we can use GDC to solve this. So to use GDC, those who are new to GDC, they can press menu and then you can go in recursion. In recursion, you will see we have to enter, and when you will see enter, you will see an, bn, cn. That I'll tell you what are these. And after enter, they'll tell you to set the values. To set the values, we are given with start, end, a0, b0, c0, and many more. And then after pressing start, we will press on table and we will get a complete table. Now how you will relate this to these formulas which are given in your formula booklet. So in your calculator you will see an plus 1. It means my x is related to n and my step value is given to me as 0.5. So and bn is related to yn. So I can write it as 0.25 into 2 an, because x is related to an square plus bn. So this is what you have to enter in your GDC. Once you will enter this in your GDC, in the set you will see start, end, a0, b0, c0. So these values will come in your GDC. So in the start, since it says it passes through 1, 0, 1, 0 is your x, y values. So 1 and 0 will be your x and y, and since we are not taking CO, so we will put CO and the rest of the thing as 0. Now we have to estimate the value of y when x is equals to 2. So we will take start point as 0, and to put end value, we will write 5 as our end value. Now when you will press table, you will see you will have a table like n plus 1, then an plus 1, and at the end bn plus 1. So here you will see in your table you must be getting these values, and this should be 1.25, Bn is coming out as 0.5, and for 1.5 it is coming as 0.083. For the third iteration, this is 1.75, 1.40486, and for the fourth iteration we are getting 1.2615. Now if you see here, they have asked us to find the value of y when x is equals to 2. So for x is equals to 2, my y value is coming as 1.2615. So this is how we can write that y value is 1.2615. Now let's move to the next part. Now in this part of the solution curve is shown to us in this diagram. We have to determine whether the answer which we got in part A is overestimated or underestimated. Now the answer will be overestimated. The reason is, as I can write that, because we have to justify, so we have to write the tangent to the curve lies above the curve, and our curve is concave down, as you can see. So this is the answer for the first part. Now it says justify why the use of Euler method starting at 1, 0 does not lead to an estimate of negative value of y when x is equals to 2. So for this, since again we have to justify, so we can write that as my gradient is positive, so method works in the direction of the upper part of the curve. So this justification we have to write. Now let's move to question number 10, and this comes under section B. Now in this question, rectangular play cards are stacked in the shape of pyramid with n rows, and number of rows will be greater than or equal to 1, and they are stacked at angle 60 degree to the horizontal, and the following diagram is given to us for 1, 2 and 3 values of n, where Tn represents the number of cards used to create the pyramid stack with n rows. We have to find T3 and T4. Now to start with, we have to first find the total number of cards in the first, second and third row. So to write this, you can start by counting. So for total cards for n is equals to 1 is 2. As you can count, 1 is this one, 1 is this one, 2. Now for the second one, the total number of cards will be 1, 2, 3, 4, 5, 6, 7. The total cards are 7. So like that, if you find for the third one, this one, the total cards will be 15. So for A part, my answer will be total cards are 15, and you can count also 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. So this is how you can count. Now to solve B part, they have asked for T4. So if I write, for the first one I got 2, for the second one I got 7, third one I got 15. So if I try to find out the difference is coming as 5, and for this the difference is coming at 3. And the common difference between these two is 3. It means the next number should also have a difference of 3. So this will come as 11, and if we add 15 to 11, we will get 26 as our answer. It means T4 is 26. Now for the C part, we have to show that Tn is this. So to solve C part, I can split this into two parts. First one is the sum of the stacked cards. I will find the nth term of this. And the second one is the horizontal cards. Now to solve for stacked cards, I can say that stacked cards are 2, 4, 6 and so on. If you want to take a look, then look into this figure. So you can see that the stacked cards are two only. In the first one, they are these and these cards, and for the second one, you can see that two are here and two are here. So it is 4. So this is how I can say that there is 2 stack, 4 and 6 stack and so on. So for this, if I try to find out the sum, so I will use the sum formula is n by 2u1 plus n minus 1 into d. So if I want to find, I will write that as n by 2 only. My u1 becomes 2. My u1 is 2, the first term, plus n minus 1 as it is. The common difference is second term minus first term, which is coming as 2. So the Sn will be 4 plus 2n minus 2, which is nothing but n by 2, 2n plus 2. So this is the sum of the total stack cards. Now to find the sum of the horizontal cards, my horizontal card series will be 0 because in the first one there was no horizontal card. In the first, for n is equals to 1, this is for n is equals to 2, I had 1 horizontal line. For n is equals to 3, I will be having 2 and so on. So for this, my Sn will be again n by 2. My u1 is 0 and the common difference is 1 minus 0, which is 1. So this is n by 2 into n minus 1. Now, because I have split it into these two, so my final sum will be the sum of these two equations, which is n by 2, 2n plus 2 plus n by 2 into n minus 1. So Sn will be n by 2. I can write it like this. So from this I can say that n is n by 2, 3n plus 1. This is what we have to prove. Now in the next part it says there are 52 cards in a full pack of playing cards. A complete pyramid stack is created by using the playing cards taken from 14 full packs, and we have to find the maximum number of rows in this stack. Now for this we will use our answer from the C part, which was n by 2, 3n plus 1. Now for one full pack we have 52 cards and they have asked for 14 full packs. So I will multiply this by 14 sorry. And it says find the maximum number. So to find the maximum number, I can write it less than or equals to. Now to solve this, since we have, this is paper 2 question, so you can use your calculators and you can first, if you want to simplify, then you can write it as 3n square plus n should be less than 52 into 14 into 2. Now to further simplify this, so 3n square plus n minus 1456 is less than equals to 0. Now by using GDC, we can get two values at 21 point this and minus 22.19. This we have to reject as number of cards cannot be negative, and my condition was less than equals to 21.86. So I can write my n value as 21. Now in the E part it says a complete pyramid stack is created using playing card taken from full packs with no cards left over. Now find the minimum number of rows in this stack. Now to solve this part, we will again use the result which we got in C part as the n by 2, 3n plus 1. Now it has to be divided by 52 because there are total 52 cards and we have to find the minimum number of rows. So to find this, it must be an integer. Now for it to be an integer, I can say that integer any k. So I can write it as n by 2, 3n plus 1 should be 52 or multiple of 52. Now again, when you will use your GDC, you can say that k value should be 13. So minimum number of rows it can stack is 13. Now the last part of the question, the long edge of each playing card is 88 mm and we have to find the minimum number of cards needed to create a complete pyramid stack with the vertical height more than 2 meters. The thickness we can ignore. So if I draw this in a triangular form, this is 88, this should also be 88 as this is 88. So I have to find the vertical height. So since this will also be 88, since it is an equilateral triangle, so I can say that this is nothing but 44. It's the half of the entire height. So now I can apply Pythagoras theorem in this, where it is 88, it is 44, this is h. So my h will be under root 88 square minus 44 square. So my height will come out as 44 root 3 mm. Now since it says that the vertical height is more than 2 meters, so we will use the conversion method, as 1 meter is 1000 millimeters. So for 2 meters I can write it as 2000 millimeters. So this height which I got, which is 44 root 3, should be, if I multiply this with n, because I have to find the minimum number of cards, this has to be greater than 2000 because it says the word more than. This is my perpendicular height, and when you will use your GDC, you will see that it is coming as 26.24, and they have asked us the minimum number of n, so I can write this as 27. Now I can find T27 using my formula which I got in C part, which is n by 2 3n plus 1. So when you will solve this, you will get T27 as 1107. Now let's move to question number 11. In this question, we have a function given to us into 3 different forms, and the graph is also given, and it has a maximum point at t is equals to 4.5. So what we have to find is the integration from 2.25 to 4.5. Since if you see this, so we are talking about the first function which is given to us. So to solve a first part, we can, instead of ft, we can put the entire function, which is 4 by 21, 1 minus cos 4 pi by 9, t minus 2.25, and we will integrate it with respect to t. Now you can use your GDC. Using GDC, we will get our answer as 0.429. So this is your answer for the first part. Now for the second part, it says find out the mode of t. As you can see, mode will be this value only. So mode I can write as 4.5. So this becomes my answer. Now for the third part, determine which is greater, the mode of t or median of t, and we have to justify also. Now for the third part, first we have to find out the integration, no, not the integration, I'm so sorry. Median will be greater, as you can see that probability of t less than 4.5 is, I can write that less than 0.5, or I can say that probability of t greater than 4.5 is more than 0.5. So I can say from this that median is greater than the mode. Now let's move to the B part. The runner who finishes the race in 3.5 hours or less are considered to be the fast runners. We have to find the probability that a runner chosen at random is a fast runner. It means since we are talking about less than 3.5 hours, so we can take our interval as 2.25 to 3.5 because it has to be less than. And when you will put your function value and integrate, so using GDC, we will get our answer as 0.1037, or approximately you can write your answer as this one. So this should be the probability answer. Now in the C part, it is again asking us to find the probability that a fast runner chosen at random finishes the race in 3 hours or less. So for this, basically we have to find the probability 3 hours or less given that the runner is faster. Or we can write this as probability of very fast runner given that it is probability of fast runner. So this we got our answer from A part as 0.0247, and we can divide it with the one which we just got in the B part. So we will get our answer as 0.238. Now let's move to the next part. Now in the D part, we have to find the lower quartile of T. Lower quartile of T means my lower values is 2.25 and upper value I can write as Q, which I don't know, which I will find, and this is coming as 0.25. So if I put my function, which is 4 by 21, 1 minus cos 4 pi by 9 T minus 2.25, and this is given to me as 0.25. Using nsolve in your GDC, I can write my answer as Q value as 4.01. So this is the lower quartile. Now each runner's time is converted to a score which is calculated as A minus BT, where T represents the time in hours. Consider the random variable P, which represents the score of a runner. It is given that EP is 100 and maximum possible score is 150. Now we have to use ET as 4.723, determine the values of A and B. Now to solve this, we will use the formula for EP. We will use the formula this, which is nothing but A minus B into E times V. This you can find out in your formula booklet. So I can write that A minus 4.72 into B is to 3B is given to me as 100, because EP was given to me as 100 in the question. So I got my first equation. Now it says maximum score is achieved when time is 2.25. So from this I can write that A minus 2.25 B, and maximum score was 150. Now again by using GDC, I will get A value as 195 and B value as 20 as my answer. Now in the F part, variance of T is given to me as 0.906. I have to find the variance of P. So to solve F part, I can write that variance of P is variance of A minus BT, and using your formula booklet, you can write this as B square variance of T, and B value, what B value you will be putting here? The one which is given to us as E part as 20 square, and variance of T is given to me as 0.906. So from there I can write that variance of P is 362.4. So this is how I will solve F part of the question. Now let's move to the question number 12. In this question, the function is given to me like this, and in A part I have to show that Fn is even function for all. Now to show that, if I replace x with minus x and I am still getting my function back, it means it is an even function. So since fx is given to me, so I will find minus x, this summation thing will remain the same. Minus 2, instead of x I will put minus x. Negative square is positive only, so I can write it as minus 2x square to the power r, which is minus x, and this thing is nothing but this. So from these two I can say that it is an even number. Now in the B first part we have to show that f3 is coming as this. So for B part, since they are talking about f3x, it means I have to calculate f1, f2 and f3x. But what is important here to note is my r is starting from 0, so before that I have to find f0 also. Student, make a mistake in this, so please note this point. So for f3x, if I put r as 0, so minus 2x square to the power 0, minus 2x square to the power 1, minus 2x square to the power 2, and minus 2x square to the power 3. Anything raised to the power 0 becomes 1. This becomes minus 2x square. This becomes 4x to the power 4, and it becomes 6. So this is how I can show my B first part. Now it says for the second part, write down a similar expression for f4 in the ascending power. So for f4, this was my first part. So for f4x, I can write that it is f3x plus one more term. So in this, my f3 I have already calculated in the first part. So I can write it like this, and it is already in the ascending power. So for f4, I just need to calculate power 4. So this I can write as 1 minus 2x square plus 4x to the power 4 minus 8x to the power 6 plus 16x to the power 8. So this entire is my answer for f4x. Now in the next part it says consider the function n tends to infinity fn defined over the domain minus k to k, and the largest possible value of small k is capital K, which we have to find. So to start with, as we know that it is minus 2x square to the power n, so it is a GP with a common difference minus 2x square, and it should converge. So to converge, this is the condition which we have to use. This is there in your formula booklet. So I can write it like this. It means x square is less than 2. Modulus I can write. So on simplifying this, I will get 1 by root 2 less than x less than 1 with positive, 1 with negative. Now they have asked for the largest value of k. So this will be my largest value of k. Now to solve second part, express fx as a rational function in this form. Now to express this, since it was written n tends to infinity, it means we can find out the sum of infinity, which is u1 upon 1 minus r. My u1 will be 1 because it was f0x, which I calculated as 1, and r I am taking as minus 2x square. So f infinity will become 1 minus 2x square, which is 1 upon 1 plus 2x square. Now if I compare this with the question, which is a plus bx square, I can say that a is 1 and b is 2. So this is my answer for the second part. Now in the next part, the function gx is defined as fx for values between 0 to k. We have to justify that g inverse x exists. Now to justify this, we can write that gx is a one-to-one function. For every value of x, we will get a unique value of gx. or we can say that we can write also, because we have to justify. So we can write that since gx is a decreasing function, or we can write that gx has no point of zero gradient, so G inverse exists. Now second part says find G inverse x. As we have justified that it exists, so we have to find the inverse. So we will first swipe x and y. I will solve second part here. So I can write that x is equals to 1 upon 1 plus 2y square. Now I have to make y as my subject. So I can write it like 1 upon x minus 1. So my y square is 1 upon 2x minus 1 upon 2. So I can further simplify this by taking LCM as 2x. So this will be 1 minus x. So y comes as 1 minus x upon 2x, which is nothing but my G inverse x. So this is my answer for G inverse x, and we have to give its domain also. So to find the domain, I can say that my x values should be greater than half and it should be less than or equal to 1. Now in the last part it says the region R is completely enclosed by the curve gx and G inverse x and x and y axis. You can see in the shaded portion we have to find out the area R, which is the shaded one. So we can first, using our GDC, we can first find out that the curve intersects at x is equals to 0.5897. So what you have to do it, you have to put your gx and G inverse x in your GDC under graphs, and from there you can press G solve and check the intersection point. You will see x values as this. But we have to find the area. So this area is formed by gx and G inverse x. So I can write that my area is from 0 to 0.5897. My gx is coming up minus the integration from 0 to the same, which is x dx. Now I can put my gx as 1 plus 2x square minus x. I can combine this, and now I can put my integration symbol like this. Now since it is paper 2, so you can use your GDC. So using GDC, when you will put this function, you will get your area value as 0.1736. But they have asked for the entire region. So for the entire region, the area of R is nothing but twice 3176, which is coming at 0. This one. So this is the answer. Alright, that brings us to the end of this paper 2 solution. If this solution helped you understand the concept and exam approach, do give the video a like. If you have any doubts or would like to see more IB past year questions, feel free to leave a comment below. Don't forget to subscribe to IB Methodology for more clear and exam focused IB math content. Thank you for watching, and I'll see you in the next video.